The Battery Buzz podcast is brought to you by H.B. Fuller Company. H.B. Fuller is one of the battery industry's leading suppliers of adhesive, encapsulant, coatings, and sealants for the EV and battery industry.
Hello and welcome to Battery Buzz, the show for battery professionals by battery professionals, keeping you connected to what's new with batteries and the people that help build them. Your battery specialist hosts today are Elizabeth Canaz and me, Jermaine Maria Selvaraj, and we are back for our next episode. So let's get started. Today, I just want to say thank you for joining us. This week, we're welcoming our special guest, Adam Harris with C-Therm Technologies. We're super excited to get Adam's perspective on the battery industry. So, Adam, thanks for joining us.
Pleasure to be with you.
So, to give you a little background on Adam, he's the CEO of C-Therm Technologies, the global leader in transient thermal conductivity instrumentation. He's been working in the field of thermal conductivity, instrumentation, and process analytical technologies for over 20 years. Adam is a long-suffering Toronto Maple Leafs fan and climbed 4 of the 7 summits. So can you give us a little insight of these summits? Because what you're referring to?
Yeah, it almost feels from a previous life now before kids, but was able really into mountaineering for a period of time and was able to climb Kilimanjaro, Elbrus in Russia, Aconcagua in Argentina, and really enjoyed the opportunity, Kosciuszko in Australia. So it was a great way to travel and to meet interesting people and go some places that otherwise might not have gotten to. So.
Wow. And then any crazy stories?
Crazy stories.
Do you want to share?
Well, the one that wasn't successful was on Denali up in Alaska. So we had quite a bit of, it was, I think, an early melt, and we had quite a bit of snow slide on the mountain. So we weren't successful on that one, but it was definitely an experience I'll never forget, being on the glacier and going over crevasses and all kinds of interesting adventures.
That sounds amazing. Well, Look at you.
Yeah, seriously. We pale in comparison. 0 summits for me.
It feels like a previous lifetime, though, since kids and everything else that goes on in life. It was quite a while ago now, but some fun memories for sure.
Yeah, absolutely. Well, that's awesome. So, let's kick off right away. Our first segment, we kind of like to go with what's new with batteries, just kind of big bullet points of news since the last time we talked, kind of in the EV and battery world. So to start off with, I think it was last week, Mercedes-Benz kind of came out with more details with their first kind of electric G-Class, which, it keeps the iconic kind of square G-Wagon shape since it's had since 1979. That's awesome. But I think the model, which is the G580, what's cool about it is that, it replaces the engines. It's got 4 electric motors, 1 at each wheel. So I think they're really trying to tout and maintain kind of the off-roading capabilities, the all-wheel drive, while being all electric. So I don't know. I think it looks awesome, and I think it's got 579 horsepower and a range which about 250 miles is what I've read. So on full charge, which isn't too bad at all for an SUV. And so I thought that was pretty cool.
Yeah, it looks like it's a little bit heavy though, kind of like Hummerish.
It does a little bit, but it's part of the G-Wagon charm, I'd say.
Yeah, and I'm sure it comes with a hefty price tag. I don't think it's in, everybody's dropping their prices. I doubt that this G-Wagon's going to come in at an economical price, at least not in my
definitely one for me to aspire to. Yeah, not right now.
Yeah, I think the price is, it's such an interesting point, right? In terms of the long-term adoption here, is seeing those prices come down. It's probably one of the most consistent points I hear at these different shows and talking to consumers is, the need to get these options at a more economical and affordable price. I think it's going to really help drive long-term adoption. We got to get there. We got to get these prices down and more accessible to the mass market.
Yeah, definitely. I think
Yeah.
that's key in adopting EVs. And so speaking of Tesla, so Tesla just announced a timeline for the production of their electrical semi-truck, with the first vehicles expected to roll out from the new factory by 2026. Uh, the engineering for the semi-truck is being finalized to enable high volume production from the construction um, of their factory in Reno, and that's already been started. I just saw a Frito-Lay semi truck, Tesla semi truck, going down the freeway by my house. It was all wrapped, and it had Frito, and it was going on. So that was really cool. So they have some on the roads. I've seen another one that just completely white that was coming towards me. I'm like, oh my God. So they're out there.
Yeah, wow. That is very cool.
Great to see, and you can see how it fits well, particularly with a lower range. I saw that on some of those routes that it's that's such a great place to bring in the technology early on, to see the deliveries in a smaller radius range versus the long haul, which of course is coming. And we're already seeing some, I think, interesting developments there. Yeah, great to see that we're actually seeing these on the road now, and hitting them in traffic.
And delivering consumer goods. So it's pretty amazing.
Yeah,
that is pretty cool. No, it's an interesting point that you brought up, Adam, because kind of talking about the long haul truck and where that development is and where that innovation is. Siemens actually successfully charged an all-electric long-haul truck with about 1 megawatt, so 1 million watts, which is kind of crazy. So they kind of created, I think the idea is that they'd create these megawatt charging stations specifically for long-haul distances in trucks. And so I think I read it was from 20 to 80% charge in about 30 minutes, which kind of helps tie in and gets it closer to the times that truckers have, right, where it's legally mandated stops. So if they can fit the charge in those breaks that they have to take anyways, it's an ideal scenario. So we're a step closer with that, which I thought was really cool.
I don't know if 30 minutes is a long enough nap, though. You might need a little bit longer.
That's true.
Just enough for a nice episode on Netflix.
Yeah. All right. Well, let's get in to learn more about C-Therm and what you do, Adam. So can you tell us, about C-Therm and how they fit into the battery space?
Yeah, absolutely. And thank you again for inviting me on. It's a real pleasure. So C-Therm Technologies, we're a Canadian tech company that's really focused on advancing the body of knowledge on thermal conductivity measurement. So we're the best in the world when it comes to transient thermal conductivity measurement. Thermal conductivity comes up a lot when we talk about batteries because so much of it is based on thermal management, and the thermal conductivity of all the different parts in an electric vehicle they play a very significant role in ultimately managing the thermal management of the device. So C-Therm, we're all about trying to empower ways to measure thermal conductivity under representative conditions, really understanding things like temperature, pressure, humidity, different levels of compression, and so forth. So we've been growing very strongly, particularly the last 5 years, which has coincided with, of course, all this exciting activity happening in the battery sector and EV sector. So we really see a tight coupling there between thermal conductivity, what we're doing there, in the battery space.
Yeah, we Jermaine and I work a lot with thermal conductivity, being adhesive suppliers, so we're very familiar with that, and it's a great technology.
Yeah, and I think it's interesting that you mentioned kind of testing thermal conductivity under specific conditions, which I think is huge, right? We get asked that all the time, and we're constantly encountering it, right? The materials that you use, that it comes into contact with, the pressure, all of that plays such a huge role. So kind of measuring it in the real life circumstance, I think, is so important.
You're absolutely right, Jermaine. It's you just think about densifying a material that has fillers in it. As you densify that material, those fillers are going to bridge the bond line more effectively. So the densification, or if it's hygroscopic, if it's picking up moisture, these are things that are going to have a significant impact on the effective thermal conductivity. And that's really key in the applications here when we're designing battery packs and some of these systems, is to make sure that we have really representative data for how that heat transfer is going to work, because it's different. If you think of battery separators as an example, it makes a difference whether they have a compressive aspect to them or if they're fully lofted. Can have a very significant impact on the real effective thermal conductivity.
Yeah, absolutely. And I guess you're kind of already touched on it a little bit and just right now, but kind of high level, maybe what are the main applications that you work with the most where you see that thermal management is so important, specifically in batteries, kind of like a high level look?
Well, thermal management is key for success in applying, batteries, electrifying our transportation, whether that's a car or an airplane or anything in between. The thermal management, it impacts the performance from a range aspect. It's also a major safety aspect. So, we really want to avoid situations where there's a potential for thermal runaway, where it becomes a safety risk. So when you look at thermal management, directly underpinning it is thermal conductivity. This is how materials transfer heat energy, and it's very important to understand it. There's such a variety of different materials used in a battery pack or in a design of some of these different subsystems. You have a lot to consider there, whether it's anisotropic, for example, so referring to whether it's oriented a different through plane than in plane direction. One of the really interesting things we've been doing a lot of work on over the last few years is really looking at the effect of the additives. So a lot of the adhesives and composites, even the case, like if you think of the case for the battery pack, these are often a composite material. So the effective thermal conductivity is really heavily dependent on the orientation of those fillers, their distribution. Fillers are what's doing the heavy lifting, we'll say, in the polymer matrix from a thermal conductivity perspective, but they tend to often want to agglomerate where they kind of stick together, or they can tend to sediment. So some really interesting aspects here at a development stage with some of these composites, and then even at a quality control level as you're manufacturing the product, to make sure that we're getting that good stability in the product. We did a really great application note there with H.B. Fuller, of course, I think it was a year or two ago now, but showed great consistency in the adhesive performance, which is great to see. We don't always see that in the industry, where there's sometimes cases where we see it more with potting compounds, for example, where the lower viscosity of the material, it tends to be more conducive to seeing that sedimentation effect, where just over time that sediment will settle to one side or another. And that has a real impact in the thermal management of where those potting compounds and adhesives are applied.
Yeah, that's super critical. And that was a great study. And we learned a lot from that working with you guys. So thank you for partnering with us on that.
It was a pleasure.
Yeah. So I guess I'm curious, for me as a consumer, what are the critical questions that I should ask, you as an equipment supplier to ensure that I get the right equipment for what I'm trying to do, whether it be a battery process line or lab testing? Like, what do you see that is important to making sure you can achieve, the results that you want?
Yeah, great question. I think I always start those conversations with just first off a statement that there's lots of good thermal conductivity methods. So there's lots of choice, but what's really important is to make sure you understand where those methods are best deployed relative to the material types they're really optimal for. So, to put it differently, there's the bad data that exists out there often comes from taking a good thermal conductivity test method and applying it on the wrong type of sample format. So method selection is really important. And there's no silver bullet out there, one method that does all the different types of materials. I mean, if you think about an electric vehicle, you've got so many different types of materials. You potentially have foils or films. You have conductive polymer composites. You get 2K adhesives. You got potting compounds. You might be getting into immersive cooling in some situations where you have a low viscosity heat transfer fluid. So for all of these different situations, they will call for different techniques quite often for really getting a good, accurate, representative thermal conductivity. That's what really prompted us to launch a new product on the market about 4 or 5 years ago called Trident by C-Therm. And what Trident does, which was quite novel at the time, was it brought together 3 of the most prominent transient methods for thermal conductivity measurement. And this takes more of like a toolbox approach, so that you really have a bit of variety there in the options of what tool to apply. I like that Maslow quote: when all you have is a hammer, everything looks like a nail, right? And so if you only have one tool for the job, you might be able to pound that screw in, but it's not necessarily the best tool for the job. So that's what we've really focused on over the last 4 or 5 years, is making sure we were putting forth options that gave particularly folks in the EV field that versatility to deal with all the different sample formats that you're gonna face in a development space, or product selection, product validation, material selection space.
So do you guys do inline testing as well, or just lab testing?
Yeah, and this is newer for us, because traditionally we are mostly found in R&D labs, helping accelerate bringing product to market faster by providing more insightful, confident thermal conductivity data. So I'd say that's that's our main value proposition, is really helping folks in that kind of scenario understand the performance of either the formulations they're developing or the materials they're selecting for incorporating in battery packs or EVs or other electronics. But what we are seeing with the growth in the EV sector, and I'm guessing that H.B. Fuller is feeling it too, is that with that, we're seeing the volumes increase on some of the adhesive product lines, some new formulations too. But if you think of an electric vehicle, it's not in some ways that different than an iPhone, right? But what is very different about it is the scale, right? So the thermal management in a smartphone is very, very important. It's critically important to that product's performance, just as it is in an EV. But what's different is it's such a larger volume. And the thing that happens with that increase in volume, now instead of dispensing out of much smaller packaging, now we're dispensing in a lot of cases out of 55-gallon drums. And so the scale is much greater, and this also introduces a bit more focus and interest around the consistency. It's easier to maintain consistency in a thimble of fluid than it is in a 55-gallon drum in a lot of cases. So we are seeing that pull into manufacturing. We've got some EV manufacturers on the West Coast that are applying it at line. So they're using the same equipment that's used in the lab, but they're deploying it at line in the manufacturing environment and testing potting compounds and samples of 2K adhesive that are extracted and tested locally. But what really has me excited, and I think I'll use the Wayne Gretzky analogy of where the puck is moving more in the future, is incorporating these sensors in line, and the feedback loop that this can create in terms of traceability, eventually thinking kind of in an industry 4.0 landscape where it becomes a more predictive analytic tool that can help you identify issues even further upstream before they become issues, combined with other data streams around pressure and viscosity and other aspects of the material in the line. But we just published a really nice application note with some colleagues at BD Tronic, which BD Tronic is a leader in the dispensing field of 2K adhesives and other materials, potting compounds and so forth. And they've introduced the sensor in line and run a couple of trials, very effective, very nice results. And I think in terms of the future, you're going to see more of that, because that filler distribution and the consistency of what's being dispensed is so critically important, ultimately supporting the overall thermal management of the product. So I think you're going to see more of that.
Interesting. Well, that's exciting.
Yeah, that is very exciting. I mean, we kind of see that a little bit, right, where we have customers ask us for repeatability, right? So dispensing large amounts and just making sure from start to finish, it looks the same, under certain conditions, so kind of that traceability, I think, is definitely coming for all of us, so it's cool that it seems like you're already ahead of it.
Yeah, I mean, you look at some of these product recalls that we've seen in the last year. I think there was one from Porsche a couple months ago. Just being able to narrow the scope of the recall. Rather than like all the vehicles produced in 2024, if you have data, and I'm not saying, and I'm not specifying that issue was related to filler or anything. I honestly don't know what the root cause of it was. But, the philosophy around traceability is, of course, that it gives you that data resource to go back to when there is a problem as well, so that you help narrow the scope of a very costly product recall. So I think to effectively do that, you need better data from different types of sensors. And thermal conductivity, I think, is part of that equation, not the only part, but I think it's an important part overall.
Yeah, absolutely. So, and it's really interesting kind of like with the sensors, like that's new information to me. You kind of talked about Trident, which, we're familiar with when, we kind of did our joint study a couple years ago. That was working out really well. Is there any other kind of new technologies or anything that you see emerging in the field of thermal conductivity testing in general, or anything that C-Therm in particular is coming out with that we should be looking out for?
Well, we're doing a lot of work on films and foils. So we see increasing demand for better characterization tool sets on thin films, on foils. Looking at anisotropy, these are, I think, really interesting areas where you get a more nuanced view. Anisotropy and really understanding that difference of the through-plane and in-plane thermal conductivity is really important. Better representing the application conditions, I think this continues to be something that we're seeing more and more recognition on the importance of across the industry. So, many standard ASTM and ISO methods out there, but and they're good ways to measure thermal conductivity. In fact, we have a number of them in our contract testing lab we work with. But you need to really represent the application conditions. I can't stress that enough.
100%.
You need to think about how that material is being presented in the product. Years ago, I remember seeing some data. It was really high thermal conductivity for a gap pad product, and it didn't really seem representative from our own experience of testing. And on closer inspection, what was happening is in that particular test setup, there was a huge force load placed on the gap pad. And again, it's the same thing. If you push hard enough, these kind of spongy materials together that have fillers in it, you can produce some really high values for heat transfer. But is it representative of how it's going to work in the application? I mean, I think that's a valid question.
Yeah. Well, Yeah, that's really interesting. Thanks for sharing that. I think we're going to start on our next segment, Battery Banter. This is where we kind of like to discuss, different topics and debate whether, we think it's viable or not. And so we're going to
Friendships could end
discuss.
here, just being completely honest. No.
So we're kind of going to discuss, how plug-in hybrid electrical vehicles versus EVs, because I know Volvo recently announced, that it's plug-in hybrid vehicle. They have their slogan, "We want to create a confident and seamless transition to the fully electric future of driving." So they're trying to bridge that gap, for somebody who doesn't want to fully commit to an EV and go in with a plug-in hybrid vehicle. I guess, what are your guys' thoughts on that? And, what are the pros and cons?
Yeah, I mean, it was funny. I was talking to my dad, because he was looking for a new car, and I was like, "Well, what about an EV?" And and that was kind of one of the things that he brought up, right? Is that going full electric, maybe he's just a little bit too scared right now, but he'd be interested in the idea of a plug-in hybrid, right? So you have the battery, you can use it and rely on it, charge every night, but for those longer distances, you don't have the range anxiety. So I kind of do see, its place in the market, at least right now in the beginning, as we transition. I don't know.
Yeah,
Yeah,
I think. Sorry,
go
go
ahead.
ahead, Liz.
No, go ahead, Adam.
I was just going to say, like, at a personal consumer level, like, so I have a Ford Explorer that's coming up off lease, and I'm having to make that kind of decision and really wanting to go electric. But this is our main vehicle for the family, and we're a hockey family. So part of our criteria is have to be able to drive in one day up to the northern part of the province of New Brunswick, which is where we live, and back, and that's about 500 kilometers in a day for these hockey games, right?
That's commitment.
Yeah, we love it though. The plugins available to me at that price point they're not quite there. But the hybrids are a great alternative, and I think a positive step both environmentally and otherwise in terms of this move towards electrification. But it does remind me of that the Toyota approach, right? Like I think they did this, was an internal study, and came up with the 1-6-90 rule, where if you look at the amount of material extracted from the earth to build these batteries and what it takes from a resource perspective, for one fully electric, you can build 6 plug-in hybrids or 90 traditional hybrids, non-plug-ins, right? So it's an interesting study or take. I don't know necessarily long term I want to be in a hybrid. I think I'd like to make that transition to fully electric. But you think of it from a resource perspective on some of these minerals and materials that are going into the battery pack, what's required there, and it might be a more balanced way for the industry to ultimately get there. Otherwise, I don't know that the material availability is there. That may also be impacting some of the cost of supply demand curves cross. So, yeah.
Yeah, I don't know. I think the maintenance aspect of it, because you get a EV, there's, essentially you buy tires every 100,000 miles. But then if you have a plug-in hybrid, you have to maintain both systems. So the maintenance is on there. So, I mean, while maybe the price may be cheaper up front for a plug-in hybrid than an electric vehicle, but then the overall total cost of ownership may be higher. So kind of see, I mean, I think just rip the Band-Aid off and get an EV.
Love it.
Well, it was funny because I was traveling, we were going through Louisiana like during Christmas time, and there was a Tesla who had a Connecticut plate, and they were all the way in Louisiana. It's like they have faith in their charging stations. I don't know if they planned it or if I don't know, what technology they used to ensure, but they did not have range anxiety.
Yeah, good for them. I would say the charging infrastructure is really where I am hesitant the most, right? I mean, I
Mm.
know in some places, maybe on the West Coast, it's a little bit better in pockets of areas, but where I'm at, Minnesota, maybe other places, the Midwest, is definitely still some charging station deserts. And that just, yeah, that's where I'm most hesitant, where maybe a plug-in hybrid would be great, just kick in when I need those long distances and I can charge every time else. I don't know.
I'm really looking forward to when we have a robust national network of charging stations. I mean, I think that's going to be the real game changer. And, seeing Tesla open up their charging network to Ford and others, that's um, a huge development as well that I think will bode really well for long-term adoption.
Yeah, and I think it's probably being in California where I live is we definitely have a more robust charging system. I would say like probably one out of every four cars is an EV, if not higher. It seems like they're everywhere, and the charging stations are going into like the grocery stores, and I mean they're in every parking lot. So you're seeing them being installed, and so I think it's probably a different scenario where I'm at versus where you guys are at. And we really have a good representation. We've got Canada, the Midwest, and California. So it couldn't be any more extreme differences.
Good continental coverage.
Yes.
Right. No, that's a good point though. But I think, yeah, you're right. I think once, especially the superchargers, and not even just having more charging stations, but also reducing that time as much as possible, right? You can't be filling up a tank of gas in, maybe a minute, 2 minutes versus having to sit there, depending on where you are, for 15 to 20 minutes, upwards of that even. But I think we're definitely getting there, especially with Tesla opening up their charging stations.
Yep. Well, exciting times. So that's all the time that we have today. Thank you for joining us. Join us next month for another episode of Battery Buzz Podcast. We'll be having another special guest, Tom Stilach from Mubia, joining us to discuss their take on the battery industry.
Yeah, so thank you, Adam, for joining. Really appreciate everything, all the insight that you've had. I definitely learned a lot, so really appreciate it.
It was a great pleasure. We love collaborating with your group, and this was a real nice discussion. We're very passionate about the future for battery and electrification. It's a very exciting time to be involved in the industry, to be part of this change. It's a once in a century development, this kind of massive mobilization effort to electrify transport. So very exciting times. Thank you again.
Yeah, no, thank you. And as Elizabeth said, thanks for everyone else for joining us. So if you have any comments or questions with the discussion, feel free to comment and give us your insights. But other than that, please subscribe, like, and follow, and check out H.B. Fuller's electric battery adhesives page on LinkedIn. Thanks, everyone.
All right. Thanks.
Thank you.